Good morning to all of you. Today we will discuss the subject mechanics of solid MOS. Last class I have discussed cantilever beam with point load. Today I will discuss cantilever beam with UDL, uniformly distributed load. Right? Cantilever beam with UDL. Clear? This is cantilever beam. AB. This is UDL. The length L. Double Newton per meter run. Clear? Suppose this point C, x from the end B. Take a section XX, a distance small x from B. Clear? Consider a cantilever beam carrying UDL W Newton per meter run over the entire beam. Over the entire beam. Clear? Let L is equal to length of beam. Take a section XX. Take a section XX at a distance small x from B. From B. Clear? Now, shear force diagram. Shear force diagram. At a B, at a B, 0. Shear force at B, 0. At X, shear force at X. Suppose W, this is W, length X, this is double X, this is X by 2, this length is X by 2. Clear? So shear force at X is equal to W into X. Shear force at A, this is a B, this is a B0, this is Fx double X, this is Fa double L. Right? Next, bending moment calculation. This is calculation, not diagram. Calculation. Next, bending moment calculation. Bending moment calculation. Clear? At B, bending moment at a B, 0. at x, bending moment at x minus double x into x square 2 minus double x square 2. Clear? Bending moment at a, bending moment at a minus double L into L by 2 minus double L square by 2. Right? This is point x. A, x, B. Clear? At B, shear force 0. At A, x double x. At A double L. Right? Now, stay all a straight line because 1 degree of x, x power 1. So this is straight line. This is double x, double L, 0. All are positive. All are positive. Now bending moment. This is shear force diagram. Next, bending moment diagram. A, x, B. At B, bending moment 0, 0. At x, minus double x square 2, minus double x square 2. At A, minus double L square 3, 2, and double L square 2. This is second power of x, second degree of x. So this is parabolic curve. 0, double square 2, double x square 2, double L square 2. This is parabolic. Parabolic. This is negative. Negative. Clear? Similarly, this shear force is first degree of x. This is straight line. This is second degree of x. This is parabolic. Clear? I'll do some problem. This is question number 47, 48. Clear? This is question 48. This is question number 48. है ना? A cantilever beam a cantilever beam 2.5 meter long, 2.5 meter long, carries a udil of 60 kilonewton per meter. 60 kilonewton per meter over length of 1.8 meter from the free end. Draw the shear force and bending moment diagram for the beam. Clear? Draw the SABM diagram for the beam. Now, this is cantilever beam. AB, total length is 2.5 meter, right? And carries a udil of 60 kilonewton per meter over length of 1.8 meter from the free end. This is free end. This is udil 60 kilonewton per meter for length of 1.8 meter. 1.8 meter. Clear? Draw the shear force bending moment diagram for the beam. Now, a step calculation. Shear force calculation. Clear? This point C. Shear force at B0. Clear? So B right side for 0. So shear force at B0. Shear force at C. Shear force at C is equal to W X 60 into 1.8. 7.2 kilonewton. 72 kilonewton. Right? At a shear force at a there is no load between A and C. There is no load between C to A. So this remains constant. Is 72 kilonewton. Right? A C B, A C B. Now at B0, at C 70 kilonewton, 70 kilonewton, at A 70 kilonewton, 70 kilonewton. Take scale 1 same is equal to 70 kilonewton. Clear? So B0, C 70 kilonewton, A 70 kilonewton. So join from B to C. This is 72. ABC. All are positive. So all are above the baseline. This is positive. Clear? Next, Bendimo diagram. Bendimo calculation. At B0, bending moment at B0, at C 16 to 1.8 to 1.8 by 2. This is 16 to 1.8. This is 1.8 by 2. What is this? 0.7. Clear? So about C, 16 to 1.8 into 1.8 by 2. So minus 16 to 1.8 to 1.8 by 2. This is bending moment at C. Clear? This is equal to minus 97.2 minus 97.2 kilonewton meter. BM at a 16 to this 16 1.8 into 0.7 plus 1.8 by 2 minus 16 1.8 into 1.8 by 2 plus 0.7. Clear? A bending moment at A, MA. This is MA. This value is minus 172.8 minus 172.8 kilonewton meter. Clear? You use calculator, find this value. Now draw the bending diagram. A, C, B. Clear? At B0, at A minus 97.2, at C minus 97.2, at A minus 170.8, This is 172.8 kilonewton meter. From B to C, udal curve, parabolic curve. Right? From C to A, no load, so straight line. This is parabolic. This is straight line. Clear? Parabolic straight line. Next question, 49. 49. This is question number 49. The question is, draw the shear force bending moment diagram for cantilever beam shown figure. The beam may be fixed at A, free at B, carries a UDL of 1200 Newton per meter for length of 1.2 meter from fixed support. Draw the SHEAR diagram for the beam. Clear? The question is, a cantilever beam may be 1.75 meter long, carries a UDL of 1200 Newton per meter for length of 1.2 meter from the fixed end A. Find, draw the SHEAR diagram. Clear? Now, first we will make shear force calculation. Shear force calculation. Clear? At B, shear force at B is equal to 0. Shear force at C is equal to 0 because at B the no force, C also no force. Shear force at A, Fx, Fa, Fb, Fc, Fa. This is 1200 into 1.2. Clear? Newton meter per meter into meter, Newton. Clear? This is 1440 Newton. 1440 Newton. Now, shear force at A is equal to 1200 into 1.2 is equal to, this is Newton per meter into meter, 1440 Newton. Right? Now, A, C, B. At B0, B0, at C0, C0, at a 1440 Newton, 1440 Newton, right? This is 0, 0, 1440 Newton, straight line, because first degree of x, clear? Is all value positive? SF diagram. Next, calculation for bending moment. BM calculation. BM calculation. At B0, bending moment at B0, at C, 0, at A, this at a 12002 or 1440 into 1.2 by 2. This is 1.2 by 2. This is 1.2 by 2, 0.6 meter. Clear? This is minus 1200 into 1.2 into 1.2 by 2. Double L into L by 2. This is 1440 into 0.6 minus 1440 into 0.6. Clear? 0.6. This is minus 864 Newton meter. Minus 864 Newton meter. Right? A, C, B. Clear? This is B0, B0, C0, C0 at a minus 864 Newton meter. Minus 864 Newton meter. This is straight line, baseline. This is parabolic curve. Parabolic. Because second degree of x. So this is parabolic. Clear? This is shear for diagram. This is SF diagram. This is BM diagram, bending moment diagram. Clear? This is shear force bend diagram, this is bending mode diagram. This is a very important question. Cantilever beam fixed at A, free at B, carries a UDL and a point load as on figure. Draw the shear force bending mode diagram for the beam. The point load is 3 kN and UDL is 2 kN per meter. The UDL is acting over length of 1.25 meter and point load is acting at 0.25 meter from the free end. Clear? Now first make calculation for shear force, then for bending moment. Now shear force calculation. Shear force calculation. Right? Shear force at B. Shear force at B 0. Now from B to D, load is 2 kN per meter for length of 0.25 meter. A D, a point load 3 kN given. So find the shear force at D, just right, just left. Shear force at D, just right. Two into 0.25. Clear? 0.5 Newton, kilonewton. At D, just left. Shear force at D, just left. 0.5 plus 3, 3.5 kilonewton. Right? Shear force at C. Shear force at C. Total 2 into 1.25 plus 3. 2 into 1.25 total load plus this UDL, this is point load 3. Clear? This is 2 into 1.25 total length to 1.25 plus 3. 2.5 plus 3, 5.5 Newton, kilonewton. 5.5 kilonewton. Clear? Similarly, shear force at A, same. Shear force at A, 5.5 kilonewton. At C, 5.5. Between C and D, there is no load. So this will continue from C to A. Draw the shear force diagram. Now, A, C, D, B. At B0 scale, 1 cm is equal to scale 1 cm 0.5 Newton, kilonewton. Clear? 1 cm is equal to 0.5 kilonewton. At B0, at D just right, 0.5 means 1 cm. Right? At D just left, 3.5. This is suppose 3.5 kilonewton. All are positive. At C, 5.5 kilonewton. This is 5.5 kilonewton. At A, 5.5 kilonewton. This is 5.5 kilonewton. Right? So start from A, B, 0, 0.5, 3.5, 5.5, 5.5. This is 0 to 5.5. This is 3.5. This is 5.5. This is 5.5. Clear? All are positive. All are positive. This is SF diagram. This is shear force diagram. Clear? At B0, D just right 0.5, just left 3.5, C 5.5, A 5.5. Then all the points, find this figure. Next, BM calculation. This is shear force calculation. This is shear force diagram. We will calculate now bending moment calculation, then bending moment diagram. BM calculation. Clear? At B, bending moment at B0, because start from B. We have already given from design point the bending moment at the free end of a cantilever beam is 0. The bending moment at the two supports or simple short beam is 0. Right? Now bending moment at D, BM at D. This is bending shear force from B to D, 2 into 0.25. This is 0.25 by 2. So negative sign. Downward, right downward. Negative anti-clockwise. So minus 2 into 0.25 into 0.25 by 2. Downward x into x by 2. Clear? This is MD. BM at D. This is MB. So MD is equal to 2 to cancel out 0.25, 0.25, 0.675, 0.625, 0.625 kilonewton meter minus when we D, then at C, clear? At C, BM at C. So for C, this will not consider for total. Now this is 2 kilonewton per meter for length of 1.25. Clear? So minus 2 into 1.25 into 1.25 2 plus 3 into 1. All are negative. Clear? 2 into 1.25 into 1.25 2. This is total load. 2 into 1.25. This is 1.25 by 2. Right? Plus 3. This is 3. 3 into 1. 3 into 1. So all are negative. All are clockwise downward, right side downward, right clockwise. All are negative. So this is 2 to cancel out. 1.2.5, 1.25 into 1.25 plus 3. This is 4.563 minus 4.563 kilonewton meter. Then BM at A, this point A. Now the total load is 2 into 1.25 into this 1.25 by 2 plus 0.25. Clear? Minus 2 into 1.25 load into 1.25 by 2 plus 0.25. Right? 2 into 1.25 into this 0.25 plus 1.25 by 2 plus 3 into this. 3 into this. What is this? 1.25. 3 into 1.25. All are negative. Clear? 2 into 1.25 into about A. 1.25 to plus 0.25 plus 3 into this 1 plus 0.25. 1.25. Clear? This is 5.94. 5.94 kilonewton meter. Right? Now draw the bending mode diagram. A, C, D, B. At B 0. At B 0. At D 0.625. This is 0.625. Clear? At C 4.563 minus 4.563 negative. At A 5.94. This is 5.94 Newton meter. Right? Zero 0.625. Next, parabolic straight line. This is parabolic. This is straight line. Noodle 4.563. So clear. This is 5.94 Newton meter, 4.563.6250. This is second degree of x, so parabolic. This is straight line. Clear? This shear flow diagram, this is Bendimo diagram, BM diagram. Right? Now, next question 51. This is question number 51. The question is, a cantilever beam may be ABCD fixed at a period point B carries UDL of 20 kN per meter, length of 2 meter, the distance 0.5 meter from the fixed support, and a load of 60 kN at point C, which is 0.5 meter from D. Clear? He is given the UDL and point load are shown figure. One line question. Clear? So point load is acting at point C, 0.5 meter from D, and 20 kN per meter, a distance of 2 meter, either from 0.5 meter from left support, fixed support, or 0.5 meter from the free end D. Clear? Draw the shear force bending diagram for the beam. Now, A, B, C, D. A, B, C, D. Clear? This is shear flow diagram. This is bending diagram. Bending diagram. Now, shear force at D. shear force at D. Shear force calculation. Zero. Clear? Let's see shear force at A. C. Zero. She right. She just right. Zero. At C, load 60 kN given is acting. So that will be calculated for left. C left. Shear force at A. C just left. 60 kilonewton. At B, shear force at B, 60 plus 20 into 2, 60 plus 20 into 2, 100 kilonewton. So between B and A, no load. So this remains same from B to A. Shear force at A, right? At D 0, she right 0, she left 60 kilonewton, B 60 plus 20 into 2, 40, so this is 100. At A, B and A there is no load, so at B means at A, 100 kilonewton. Clear? Now, draw the shear force diagram. Take scale, 1 cm is equal to 50 kilonewton. 50 kilonewton. Now, at B, at D0, she right 0, she left 60 kilonewton, 60 kilonewton. A at B, 100 kilonewton, 100 kilonewton. At A, 100 kilonewton. Clear? D to C, right? All are positive. So the diagram is above the baseline. Clear? Now make calculation for bending moment. BM calculation. At D, BM at D 0, right? At C also 0. D0, C0. At C, load 60 Newton is acting, 60 kilonewton acting. So start from C. So this we calculate for B. So when you want B, /16 into 2 plus 20 into 2, 40 kilonewton, clear, into this. This is 20 2 by 2, 1. Right. This is downward moment, right clockwise negative, minus 16 to 2 plus 20 into 2 into 2 by 2. All are negative, both are negative. Clear? So this is minus 120 plus 40 minus 160 Newton, kilonewton, kilometer. Now, take shift into this. It 60 into 2 plus 0.25, 2 plus 0.5. Clear? 60 into 2 plus 0.5 plus continue this. Continue plus this is 40, 40 into 1 plus 0.5 plus 40 into 0.5 plus 2 by 2. All are negative, both are negative. Clear? So this is minus 210. 2 to cancel out. 2.5 into 60 minus 60 into 2.5 plus 40 into 1.5. 60 plus 150. This is minus 60 into 25 by 10 plus 40 into 50 by 10. 0 0 cancel out. So 150 plus 40, 60, 210. This is minus 210. Minus 210 kilonewton meter. Right? This is minus 210, minus 160, 0, 0. Now, say D0, C0, D0, C0, at B, minus 160. This is B, minus 160 kilonewton meter. Take scale, 1 same is called 50 kilonewton meter. Clear? Take scale, 1 same is equal to 50 kilonewton meter. This is 210. So this is 210. Newton meter. Right? Now join all points. 0. This is parabolic curve. This is straight line. Clear? This is parabolic. This is straight line. Now, clear? This all are negative, so this is downwards. All are negative, so the diagram is below the baseline. Positive, so shear force diagram is above the baseline. Clear? This is UDL, this is parabolic, this is straight line. Clear? This zero starts from zero, this is inclined straight line, this is fixed, so horizontal straight line. Right? This is shear force diagram, bending moment diagram, that is shear force calculation. This is bending moment calculation. Next class, I will do simple supported beam. The shear force bending moment diagram for simply supported beam. Right? Now, you make likes and subscribe to all our videos. Thank you.